State the natural domain and corresponding range of the function f of x is 3 plus 4x over x minus 2. A little sketch might help us with this. And this is the type of function that you should recognize from your Year 11 Methods course. So looking at the bottom here, we can't have the value 2 because we'd be dividing by 0. And that tells you that x equals 2 would be a vertical asymptote. Now, if we think about a horizontal asymptote for this, think about making x a really, really big number. That means that the 3 and the negative 2 being constants would become inconsequential. When x becomes very, very big, essentially what we have is 4x over x, which is equal to 4. So it's not going to be able to take the value 4, the function itself won't be able to take the value 4, because we always have a little bit on the top added to the 4x, and a little bit on the bottom taken away from that. So you can never actually get 4x over x equals 4. So that's going to be the horizontal asymptote. So that is going to be y equals 4. And the function is probably going to go here and here. We could actually just check that out. Let's put a x equals 3 into it, and then we're going to get 15 over 1, and yeah, so it would be up in this section here. It could have been in the other section, I just needed to check. So that's going to help us with the domain and range. So the domain is going to be that x is a real value, but it cannot take the value 2, as we discussed. The range is going to be that y is a real value, but y will not be able to take the value 4. That's why we have that horizontal asymptote there. Find an expression for the inverse function and state its domain and range. So, same procedure that we've had before. Y is 3 plus 4x over x minus 2. Interchange x and y. X is equal to 3 plus 4y over y minus 2. Now we want to make y the subject, and so x y minus 2 is equal to 3 plus 4y. Gives us xy take away 2x is 3 plus 4y. Get all the y's to one side. Xy minus 4y would be equal to, put the x's on the other side, 2x plus 3. Factor out the y. And then y is going to be 2x plus 3 over x minus 4. Okay, so because of the relationship that we know between function going that way and the inverse function going that way, the domain and range switch over. So we can state the domain and range for this by swapping those over. The domain is going to be x is a real, x cannot be 4. So that's from the range here. The range is going to be y is a real, but y cannot be 2. And that comes from the domain there. But we can see it from the function itself. Look at the bottom. If we have x equals 4, we've got 0 on the bottom. Okay, then if we consider x being really, really big, and ignoring the 3 and the negative 4, we've got 2x over x, which is equal to 2, but it won't be able to take that value because of the 3 and the 4, always nudging it slightly away from being 2x over x. So it all fits together.